Hello, this is a Algebra 1 video. It is Chapter 6, Section 5, and today we'll be talking about applying systems of linear equations. Obviously in the past 4 sections we've been dealing with the 3 different methods of solving a system of equations. We have a method for graphing, substitution, and elimination. And so today one of the first we're going to be working on is trying to determine which of the 3 methods is the best method to actually solve a system, and that kind of depends on how the system is set up. So here we have some general guidelines. Now obviously you can solve any system with either of these methods and it will still work, but we want to obviously minimize our time and we want to be efficient. So most of the time you want to pick which method would be best suited for each system. So when you're graphing is generally going to be the best method if both equations are already in what we call slope-intercept form, or basically y equals mx plus b. It's also good for estimating solutions because sometimes when you're graphing, because the graphs are a little bit skewed because your ruler's not straight or because we're just imperfect and we can't get the exact answer, we can at least estimate the solution because we know more or less where they're going to cross. But if the 2 lines don't cross in exactly the right spot, then it's going to be better for us to use a more algebraic method instead of a graphing method for that. So that's the graphing one. For substitution you want to use whenever one of the variables in either of the equations has coefficients of 1 or -1, and we did that in the 6.2 lesson. And then 6.3 and 6.4 we spent doing elimination, and there's basically 2 tiers of elimination. There's the easier one, which is the first tier here, and the second one where it gets more complicated. So if you want to use the first tier, basically that's going to happen whenever one of the variables has opposite coefficients in the 2 equations. So it's already kind of set up for you. All you have to do is add the 2 equations together. That's option 1. But in option 2 for elimination is when none of the coefficients are 1 or -1 and they're not opposites. So then you have to use multiplication first and then you can add the 2 equations together. So just a little bit of recap of what the methods were and also some guidelines on when to use which. So our first example is going to be to determine the best method to solve the system of this equations, and then we're going to solve the actual system. So the best method, we'll notice here that we have, none of our variables have opposite coefficients. We have a 4 and a -8, a -4 and a +1, and they're not in y equals mx plus b, so that's not going to be a graphing scenario, and it's not going to be an elimination scenario. But we can use substitution because one of the criteria for substitution was that at least one of the variables had a coefficient of 1. And it turns out that right here, this equation has a coefficient of 1 for the y variable. So what I'm going to do is I'm going to take that equation and I'm going to solve it for y. So we're going to get y equals, I'm going to add the 8x to both sides. And we get that y equals 8x plus 19. So first off, we want to determine the best method. We want to actually state that it's substitution that we're using. Substitution in this case. And then we want to actually solve the system. So that's why I solve for y. And then with substitution, we take the original, the other equation, the 4x minus 4y equals 8. And we're going to replace the y variable with what we just determined y is 8x plus 19. And that's pretty much all we're going to do. Now we're just going to do some algebra to solve for the variable. So 4x minus 4 times 8 will be 32x, and -4 times positive 19. We'll calculate that real quick. And we'll get -76. So just don't forget to distribute to both. So -4 times 8x is -32x, and -4 times positive 19 will be -76. Then we have 4x minus 32x, which is going to give us a -28. We also want to add the 76 to the other side while we're at it. So 76 plus 8 is going to give us 84. And then lastly, we want to divide by -28 on both sides. And we get -3. So just like that, we have our x variable. And then to find our y variable, we're going to come back to our equation over here. We know that y equals 8x plus 19. And since we just determined that x equals negative 3, we plug that in there. And 8 times negative 3 will give us negative 24 plus 19, which will give us negative 5. And so now we have our solution, which the x-coordinate always goes first. We want to go in alphabetical order here, so the x-coordinate alphabetically goes first. So we have negative 3, and our y-coordinate is negative 5. And this is our solution to our system. And we use substitution to solve it. So now we have a two-part do-it-yourself question. This is the first part, and it's the same question, but there's actually A, B, C, and D. I wanted to make sure you had enough space. So this is just the A and B portion. And then you have the C and D portion. And then we'll go to example 2, which is a word problem. It's a very short lesson. We only have 2 examples today. And we're talking about penguins. I hope you like penguins. I've never really talked to a penguin, but I'm sure it would be fun. It says, of the 17 species of penguins in the world, the largest species is the emperor penguin. One of the smallest is the Galapagos penguin. The total height of the 2 penguins is 169 centimeters. The emperor penguin is 22 centimeters more than twice the height of the Galapagos penguin. Find the height of each penguin. So the first thing we have to do here is kind of define some variables, set up a system, and then solve it. So we're going to go ahead and say that x, for example, we'll say that x is the height of the emperor penguin. I'm going to use EP to abbreviate there. And we'll say that y is the height of the Galapagos penguin. And it says here in the, I think, third sentence that the total height of the 2 penguins, so x plus y, the total height of the 2 penguins is 169 centimeters. So that tells us that when we add the 2 heights together, so x plus y, we get 169. The second equation is going to come from the 4th sentence, which says the emperor penguin, which we are claiming is x. So the emperor penguin, we'll put x there, is, that's the equal sign, and it is 22 centimeters more than. So we're going to add 22 to something. It's going to be 22 centimeters more than twice, so 2 times something. Twice what? Twice the height of the Galapagos penguin. And the Galapagos penguin was y, so basically x is going to equal 2 times y plus 22. And then they want us to solve this system. So we have our we've defined our variables, we set up a system, and now we think about which system would be best to solve this. Obviously, graphing is not going to be the one. But again, we have the second equation where the x variable has a coefficient of 1, and it's already solved for us. So this will definitely be a good candidate for substitution. And that's exactly what we're going to do. So we're going to rewrite the first equation. X plus y equals 169. But instead of x, we're going to replace it with what x represents, which is 2y plus 22. Now we have an equation in one variable, we can solve this a lot easier. So 2y plus 22 plus y equals 169, and we can subtract the 22 to the other side. And then on the left, we can combine our 2y and our 1y to get 3y. And 169 minus 22 is going to be 147. And then we divide by 3, and 3 goes into 147, a total of 49 times. So y is 49, and once we know that y is 49, we can come back over here and determine what x is, because we know that x is 2 times y plus 22. And since y is 49, we plug that in right there. So 2 times 49 is going to give us 98. So that's twice the value of y, and then we're going to add 22 to it, and x is 120. So in this case, let's find the height of each penguin. So x was the emperor penguin, so the emperor penguin is 120 centimeters, and the Galapagos penguin, which was y, is 49 centimeters. So there's your smallest penguin, and here's your largest penguin. and combined they have a height of 169. And that is how you do that. And so this is the do-it-yourself question, and once you have completed this question, then you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.